My name is Zaman. I am the director of MIT Virtual Experience Design Lab and a lecturer in the Department of Architecture. My research focuses on understanding human experience in immersive media and the development of tools that augment human creative and performative skills. I am currently working on a research project that focuses on conveying an expert's knowledge into a novice, in particular an expert pianist's knowledge into a piano learner. It's a very challenging task. Piano learning takes years and requires repeated exercise and training and a supervision by an expert. But most people doesn't have that sort of access to experts and time. So we are trying to understand if we can capture the experts' knowledge, how they play, how they move their hands, and then put this into the hands of a novice using a mixed reality. So we are developing this application and testing with the users. And that's very exciting because we already seen that just putting an expert's hands in space in mixed reality increases highly the engagement of the novice and makes them more excited about learning intricate movements involved in piano playing. This is a petri dish for us. It's fun to play with piano. It's fun to work with pianists, but in the end, essentially what we are trying to do is developing methods for capturing intricate skills. It would be piano playing, but it could be any task that involves an expert's knowledge and practice. For example, a worker in the field using a welding machine. It's also a hard task to learn. It also requires an expert's supervision. So we are now looking into ways of capturing this type of practical knowledge and making it much easier to learn those. It's an embodied process. That's why mixed reality is an essential part of it. When people see hands in space, being able to replicate and mimic the movements, they essentially learn more effectively and it sticks with them a longer time. The potential applications of this in the long run is enabling the training of any individual, whether it's a worker or a student of any practice, at scale. There are a lot of situations where a worker needs to learn something risky or deal with a tool that is very expensive, and they need hands-on practice to actually learn it. So in these situations, instead of getting an expert each time with the novice to train them on the task, using simulations like the ones that we are developing, you can easily train people without the risks involved in a field. You can train a worker that deals with dangerous materials or gases. In that situations, you don't need to put them in that risk and just use a simulation to train them. So this, I think, is the exciting direction we can take after really understanding how to represent this type of knowledge.